Hi, I'm Alvin Mudhui, and I would like to explain how I wrote my code. So I created class employees. Then in the class employees, I created a constructor which takes a string with the name CVS. And the first thing was to make sure the data entered by the user is valid. So as you can see, when CVS is null or it is empty, we are going to throw an exception. So that is first part of validation. So the second part was to read line by line, then get the number of commas so that we can know if the lines are valid. So if number of commas are not true, then we are going to throw an exception because that is not an acceptable data. Then the third part was to check the validity of salary. So as you can see, we try to pass salary from string to integer n. So if this operation is successful, then salary is a valid integer. Then there is check of duplicate lines. In case the user has defined duplicate lines, we are going to throw an exception here to show that duplicate lines are not allowed. Then we have to check through the lines provided by the user to check if at least there is one CEO in the lines. So this is the code for checking. So we look from 0 to the number of lines minus 1. Then we continue checking if there is a manager who doesn't have is or a field because that is the CEO. So if we get one of those field, we are going to say then there is a CEO. Else we can check also other things, like to check if manager is existing as an employee in this case, and in case two employees are referring to each other or are being managing each other, then that is a circular reference which is not allowed, so we throw an exception. Then we keep checking if manager exists as an employee. If CEO is not existing, we throw an exception so that we can't continue with executing invalid data. So from here, after validating our data, we have to perform sort depending on the dependence of the lines. In order to do so, we are going to use topology to create a graph whereby we can sort all the lines according to dependency. Because without sorting, we will not be able to add the lines as required in the nodes. So here is a bit of explanation of how I did the topology sort. So these are sample problems as A, B, C, D, E, F, G, H, I, J. So these are the vertex, these are edges, and as you can see we have A which is being dependent by B, and G is depending on B, F is depending on C, and so on and so on, but some of the elements are free. For example, in our problem we are going to have someone like CO. CO won't be depending on anyone, so in that case our CO will be like something like this, like J. So to solve this, we are going to create a matrix in the program. In that matrix, we also create another array of vertices with key of each element. Then we create another empty array of sorted elements. As you can see over here, this is the array of sorted elements, this is the array of the vertices, and this is the matrix which is empty now. But in order to work on this, we have to initialize all elements, all vertices in the matrix to zeros. So the next thing is to add edges. In this case, we have A and B, they have an edge over here. So we are going to look in the vertices tab array, whereby we have A, its key is 0, so that represents this row 0 over here. Then we have B, whose key is 1, which represents this column over here. But in this case we have not indicated that this is an edge. So to do so, we are going to change this 0 in this case to 1. So 1 will indicate that we have an edge between A, which is 0, and B, which is 1, as shown here. Then we'll move forward to the next element, which is our vertex, which is B, key 1, and G, key 7. So we have B over here and G over here. So we have to indicate that is an edge by changing the 0 in this case to 1. Then we continue to the next vertex, which is C. So in this case we have A and C, they have an edge. So key A has key 0, which is row 0 over here. C has key 2, which is column 2 over here. So we need to change this into 1, like that. So that is an indication that we have an edge between C and A. Then we continue to go forward. So we have two vertices, which is C and F, and they have an edge. So we are going to add an indication in our matrix that C and F have an edge. So to do so, you are going to find the location, which is this location over here. then change it into 1. That indicates that you have an edge between C and F. The same continues between A and D, which is this 0, we are going to change it into 1. Like that. Then continue with the D and E. So this D has key 3, so that is row 3. Then we have E, which is key 4, that is column 4, so change that into 1. Next is this inch over here. We have H, which is key 6. Key 6 is row 6 over here. Then we have I, then we have high key 8. Key 8 is column 8 over here. Now change that into 1 to indicate that is an inch. Then we continue. So after making sure we have added all our edges, you can see that G doesn't have any edge, so we are not going to add anything related to it. So it is time to sort. In order to sort this thing, we have to find any element that has no successor. Like for example, G has no successor, I has no successor, he has no successor, F has no successor, and G has no successor. So in order to find the elements in computation in our program, we are going to loop through by starting with our rows and check through if all the edges indication over here are 0. If they are 0, it means that vertex has no successor. If there is a 1, it means that the vertex has a successor, so we can't sort it at that time. So let us perform this process. So we are going to start with F, as you can see from our vertices table. So this is the vertex A. So in A, you can see we have 0, which is row 0 over here. Then we are going to loop through the columns. So we are going to start with this one and then come to this one. But you'll find that we have 1 over here. This indicates that A has a successor, which in this case, as you can see, it is B. So we are going to move to the next vertex in our table over here, which is B. Okay, now we have B. As you can see, B has key 1, which is 1 over here. Then we are going to start again from 0 because we are going to loop through the columns. So in this case, we have 0. Again, 0, then 0, 0. Again 0. As we go through, 0, 0, another 0. Here we go. This vertex has a successor, so we can't sort it right now. So we are going to go to the next vertex in our table, which is C with key 2, like that. So let us loop again through the columns. We have 0, 0 again, 0, 0 as you can see, 0, Again, we have a 1 over here. Sorry about that. Indicates that C has a successor. As you can see, in this case is F. So we can't sort C right now. We are going to continue the operation. So the next vertex in our table here, it is D with key 3. As you can see. So we have 3, and then we are going to loop again in the columns to check if all the columns are zeros in that row. So let us start again. We have 0, 0, 0, 0, so we go through, but 1 is found again. So it means that D has a successor, as you can see over here, which is E. That can be confirmed from here and here. We have 4 as key, 4 as key, which is E. Graphically you can see this, but this is what computer will be doing because it cannot visualize this. It has to use a table like this to have a presentation of this graph over here. So this matrix makes everything simple. So we are going to go to the next, which is 4, which is E. So row E, as you can see, we are going to loop through the columns again, starting from 0. So that is a 0. Let us go through 0 again, 0 again, 0 again, 0 again, 0 again, 0, another 0 over here, another 0 over here, as you can see, another 0 over here. So we have completed our column, but there is no one which is found. This means that there is no edge in key 4, which represents E. So E has no edge, which means it has no successor, as you can see. So in this case, we are going to sort now E. So that E, we are going to move it over here to the sorted array backwards. So we are going to start at index 9, not index 0. So after adding it over here, we are going to delete it. And in order to delete E, we have to eliminate it over here, then shift these rows upwards with their values. So that is the process of deleting. Then, as you can see, we have deleted E in our table, then shifted F, H, G, I, J. Then this blank for now. Then the next step of deleting, because we have not completed the deletion, we are going to shift our matrix rows upwards, because these 4 we are going to remove its values. So we are going again to shift over here upwards to 4, which means the values of 5 will now go to 4, the values of 6 will now go to 5. For example, in this case, this one has to move over here like this. It moves over there, then this place, the row 9 is empty, all unused. Again, step number 3, we are going to shift the columns in the left side, because we are going again to delete the values of this column 4. To do so, we are going to shift the values to column 4 in the left side. So the values of column 5 will now go to column 4, the values of column 6 will now go to column 5, and so on and so on. which means 9 will be unused, like that. Then the number of vertices has now reduced from 10 to 9. So it is also good to keep the track of the number of vertices remaining, so that the system can be able to find the correct values and perform the correct operations. So we are now going to find again, using the same criteria. We are going to move through the rows, like row 1 has 1, which means that it has successors, same as 1, same as 2, but 3 has 0 0, as you can see, which means 3, which is D over here, has no successor. As you can see, D has no successor, so we are going to move again that D over here, then delete it. So to delete it, we are going again to move to shift these things up, and then this place will be unused, as you can see again in this case, and our matrix is now shrinking, and our graph elements are now reducing. As you can see, we are remaining with 8 now. So we go to the next to find. So in this case we have 1 1 1, so this means these are 0 1 and 2 as successors, but 3 again has no successor, so we can sort that. So we are going to move 3, which is F, to the sorted array, then delete F and shift upwards. As you can see, we have deleted F, and F now is gone. The same process continues to find again an element that has no successor. So this one has successor, this one has successor, 0 0 0, this has no successor. So which element is that? It is key 2, C. C has no successor, as you can see over here. So we are going to delete this, because we are going to insert it in the sorted array. So we are going to have that. Again, we are going to find an element that has no successor. In this case, we are going to start again from here, from row 0. 1 has successor, 0 has successor, 1 has successor, as you can see over here, 2 has successor, 3 again has no successor. And which element is that again? It is 3. As you can see over there, it is 3. So that 3, we are going to move the G, because the G is the value, to the sorted array, then delete this G over here, and eliminate it in this, and the same way in this column. That is the result. We go next to find an element that has no successor. So 0 1, this has successor, so 0 has successor, 1 has no successor. In this case, as you can see, you have 1, so 1 is B. We move B to the sorted, then delete that B. So B is gone. We have deleted it from the vertices table and again from the matrix. We go to the next. So 0 has successor, 1 now has successor, 2 has no successor. So you can see 2 is the high. In the graphical presentation, high has no successor. So move the high to the sorted array, then delete it. Now we move forward again. 0 1, this has successor, but 1 has no successor. So 1 is H, move H to the sorted array, then delete it. Let us continue. So in this case we have 0 0 0 0, this has no successor, so we are going to 0, which is 0 over here. So A has no successor, so we are going to move it over here, then delete it, and then delete again from the matrix. So as you can see over here, already J has no successor. In case you have one over here, it means that you are having a cyclic, all circular reference. So if you are going to develop a method to check that, to check for cyclic, if you loop through the sorry about that, if you loop through the elements and you find there's no element that has no successor, it means that you are having circular reference. So in this case, if we end that, we have supposed to throw an exception to show to user that he or she had a cyclic or a circular reference. So let us continue. So H is remaining over here. You have H as you can see 0 has no successor. So you put H to the sorted array, then delete it from the matrix and the vertices, and as you can see the number of vertices is 0. So that is how topology is going to work. So in the code, let me show you. You have this topology. We have a constructor for initializing. So add vertices, that will be used for adding vertices. Add edge will be used for adding edge, as I've shown you. So this is the code. Then sorting. So we are going to while until there are no vertices and check if there is no successor, as we have done in the presentation. And if there is no element that has, there's no element that does not have successor, it means that we have circular reference. So we are going to throw an exception over here. So then this is the case for exception, does not occur always. So the normal operation is that you are going to find an element, a vertices that has no successor. Then that vertex is added to the sorted array, then delete it. Simple is that. Then after doing all that, you return the sorted array. So that was very useful for sorting our dependencies between in employees. So let me show you how to integrate the topology with the class employee after getting the string. So here's the sorting depending on the managers. So we are going to analyze the string, then identify the manager, employee, and the salary. From that, we are going to sort backwards, so that we can put the last field in the list as CEO. So I'm using node to perform that. Then add employee. So before I continue with the node, let me show you how the node is working. So we have the code. The constructor is going to create a node as the one shown. Here's the constructor. We have employee ID, a string, we have a manager, a string again, suddenly a integer, then we have a null over here, which is node in form of array. This is very crucial because node in form of array is going to allow us to attach multiple nodes to this single node. So it is very important we have an array over here. If you don't have an array, you can only attach one. So let us continue. So the constructor will be responsible for adding CEO. So in our example over here, our CEO is employee 1 because he or she has no manager with a salary of $1,000. So this is going to be passed through the constructor. That is going to be passed through the constructor. So you have employee 1 over here to be set over here. Manager is now empty. Salary over here. Then null, as you can see here. So that null will also play a crucial role because we have not attached anything. So the node array is null for now. So we go to employee 2, and we have a method that is going to add an employee, as you have seen in the code. So I have a method add employee over here. It is taking employee ID, manager, and salary. So in this case, our employee ID is 2. Employee ID 1 is manager, and the salary is 500. So that one is going to be passed over here. So we are going to check if next is null. So this next, in this case, it is our first node over here. So this next now is null. So this applies over here. So if it is null, we are going to check if the employee ID is equals to that of the manager. That is, we are going to check that if this employee is managed by this manager. So in this case, this constructor over here will create this node. Then we are going again to assign this node to an array. So we are going to create an array of the node, of this node. Then after creating that array, then we are going to put this array with the node into the existing node, in this case, which is the node of the CEO, as shown over here. So this is an array. So we have index 0 with this node, which is our node over here. So this one is assigned over here. So it's like attaching this to this. And now we are done with that, because after this there is no other statement we are going to return. So adding employee 2 is complete. So we are going to employee 5. Employee 5, yes. So employee 5 is managed by employee 1, which is the CEO. So let us do that. We have employee 5, and then over here employee 1 is the manager, then salary. So we are going to check if next is null. So we are going again to start from initial. In this case, our next is not null. So if it is not null, we are going to use now this case over here. Now using this case, we are going again to check if this employee is managed by this, equals to the employee over here. So this employee 5 is managed by employee 1. So if employee 5 is managed by employee 1, this is the statement for checking if, then we are going to add this node to the same, we are going to attach to the employee 1. To do that, remember that we are using arrays in next. So we are going to use, because this next next is not null, it means that there is an element in that array. And in our case now, our array has size of 1. So we cannot just add an element to index 1 because the existing array has size of 1. So what we are going to do, it is merge. And that's why we have the existing array of which is equal to next, and then we are going to merge with the new created array which will have this node, as you can see over here. Then merge them, and see the merged array again is equal to next. So it will be something like this. The merged array which will contain this and this is now equal to the next. The next is this whole block. So it is going to look something. It is going to look like this: 0 and 1. Then we return. It means that employee 5 has been added successfully. We go next. Next is employee 3. Employee 3 is managed by 1 and has salary of 800. So that is employee 3, employee 1, 800. So we are going to check again, starting from our root node, which is the CEO. If next is null, in this case next is not null, so that case does not apply. So we jump into the else part, this else part, and check again if this employee ID is managed by this manager. So in this case that is true. So we are going to do the same way we have done in the other element 2 here. We are going to create the new node, which is this one, put it into array. We are now going to encapsulate this one into array, then merge the array, this the existing array, which is 0 and 1, this and this, merge them to form a single array. Then that merged array is going to be assigned to next, this whole block. So it is going to look like 0, 1 and 2. Then we are going to go to next. Next is adding employee 4 managed by employee 2 with the salary of 500. So these the constructor, let me go bit by bit. So we are going to have employee ID over here, which is employee 4, employee 2, 500. We are going to check if next of the starting array, not array, of the starting node is null. In this case is not null. So we are going to jump into this else part. Then we are going to check if employee 2 is managed by this, employee 4 is managed by employee 1. In this case, no. So we are going now to jump again into the else part. Here things get interesting because we are going to use for loop in order to go through all these elements in our array, because we don't know where employee 2 is located and the system doesn't know. But here you can visualize 2 is over here, but the program has to use computational means to locate the right node. So in order to do that, we have found that our next is not null. Again, we have found that this employee is not managed by this, so jumped into else part. So we are going again to start from 0, which is this 0, then go to next of that 0, which is this node. After doing so, remember that it's append in loop. We have just executed 0. After doing so, we are going again to go through again, because as you can see over here we have and employee. So we are going to come again to this method of the same node to check that if this employee is managed by this. So in this case, we are passed our employee ID, which is 4, manager is employee 2, then salary is 500. Then check if next is null. Yes, it is null over here. So if it is null over there, check if this employee is managed by this. In this case, that is true. So if it is true and this one is null, we are now going to create an array of nodes to put our node inside, then assign it to the null part. So we have put our array, then we have assigned it to the null part, like that. So with that, we are going to check how to determine salary budget of a certain employee. So to do that, I have a method called get salary budget. You are going only to pass one thing, which is an employee ID. So let us start. Yeah, I have a test data over here. So this is the data we earlier discussed on, and this data has created this node linking. So we are going to test this method using this data. Now to test it, we are going to pass like employee 1, check the salary budget of employee 1. So in this string over here we have employee 1. So if employee ID equal to employee ID in the first thing, in the first node, because we are on the first node, then set, which is true for now. So we are going to set salary summation as applicable, which means it is now applicable to start adding the salaries of other employees in that linked with that node. So this is a global variable. Sorry for that. This is a global variable. So in this case is set true. So we are going to continue again to check if summation is applicable, and we have already set that to true. So now it is applicable. So salary budget, which is a global variable, we are going to add the salary of the employee, in this case 1,000. So that is an increment, and check again if next is not null. In this case it is not null. It means that it is attached to other elements. So if it is not null, like in our case, we're going to loop through the node arrays. So we are going to start with 0. So with 0, we are going to go to next, then go again to our method, perform the computation. So in this case it is employee 2. Employee 2, this won't apply again because already it has been set, though it is false for now. So we are going to jump direct over here to check if summation is applicable. Yes, it is applicable. So we are going to add the salary for now, which is 500. Then check again if next is null. In this case it is not null. So we are going again to start for from 0. Remember that in this node you also have a 4 which is at 0, and now we have another 4 which now is at 0 over here. So with that we are going to go to next and then request, then get salary budget method again, perform the same task. So in this case we are at here, pass employee 4 ID in this. This is not applicable because it is false, but already the summation is applicable. So we are going to add the salary as shown over here. Check if it is not null. In this case it is null. So if it is null, you are going just to assume that, not assuming, but in computation, the loop which was here, if it can increment, it will increment because we are at this. But in our case, we just have 0, so the loop won't go on again. But again, there was another pending loop here. So that pending loop is going to increment with 1 to come to 1. And remember that we have added 1,000, 500, 500 and 500. So that is 2,000. Now we are going to increment that loop again over here because we were here, and tell it to go to the next. Then that next is this. Use that get salary budget, this case. Then we are going to pass employee 5 because we are at this node. Employee 5, I'm going to check if summation is applicable. Yes, it is applicable over here because this one will turn out to be false. So we are going direct over here. So summation is applicable. Then add the salary, which is 500. Now that comes to 2,500. Check if next is null. Yes, it is null. So you are going to do nothing. And by doing nothing, you are going to increment the loop which is still pending over here with 1 to go to 2. So for now we have 1,000, 15, 2,000 and 2,500. So now we have gone to 2. So we are at this node. So pass 3 over here. This is false, so we are going to go here. Is summation applicable? Yes, it is applicable. So add the salary which is 800. That comes to that 3. So having that 3, you're going to check if it is null over here. Yes, it is null, so we are going to do nothing, and this loop is complete. So our operation is complete. The sum of the salary is that 300, which is the expected value over here. And as you can see, employee 1 salary budget should be that 300. To check for employee 2, we are going to start again afresh, pass employee 2 over here as an ID check. So when you pass it, we start from the initial node, which is the root node or the serial node for now. So employee ID employee 2, check if employee 2 is equal to this. That is not the case. If it is not the case, we go forward. Is salary summation applicable? No, because we have not turned that into true. So jump into the else part over here. Else part over here. So check if next is null. So in our case, next is not null. So we are going to start looping in this array. So start with 0, then go to next, which is in this case to hop. Start call our method again over here, pass employee 2. Employee 2 is the ID over here. Check if it is the same. Yes, it is the same now. So set summation is applicable, true. So start summation over here because it is applicable. So we are going to increment the salary budget. So we are going to add 500 over here. So now we have 500. And go next here to check if this is null. It's not null. So we start another for loop. And remember, here we have a for loop which is pending. So we are calling now another loop. So that loop, it starts from 0, it checks yes, 0 is there. It goes next over here and tells the next to call the same method again. So calling this method, we are going to pass employee 4 ID. This is false for now, although we have already set true, so it is not applicable for that case. So salary summation is true, it's applicable. So add that salary of employee 4, which is 500, to the other 500, you get 1,000. Then check if it is null. Yes, it is null. So do nothing. Remember that we end a loop over here, but it has just as one element, so that loop is going to terminate. We have already found our elements, our nodes, and we have executed all the loops. So the operation is complete, and we have those 500 and 500 added together, and we got 1,000, as you can see over here for employee 2. The same goes on to employee 3. Employee 3, we are going to pass 3 over here, employee 3. Then so when we pass that, we are going to start afresh again over here. So we start afresh. So in this case, this is not employee 3, so we are going to go, because this is false, drop down, summation is not applicable. If it is not applicable, we are going to go to the else part. Our for loop, that for loop will start with 0 until the 0, go to next and use that next to call the get salary budget again. So pass 2 over here, employee 2 over here. It is not the same, it is not applicable. We go to the else part. This one is not null, this one is not null, so 0 again. Then we call next over here, then pass the 4, employee 4 ID there. Check if if they are the same. No, employee 4 is not same as employee 3, so that is false. Summation of salary is not applicable. Go to the else part, check if it is null. Yes, it is null. Then remember, here we have our loop which is pending, and here we have our loop which is pending, but this loop just has one element, so it terminates because it cannot continue. And then we have already completed the operations in both nodes, so we are going to go to the next. We are going to loop again to the next node. So we are going to have one. So one, employee 5 again, because we are going to call this budget, get salary budget over here. Pass employee 5, employee 5. Employee 5 is not the same as employee 3, so false. Go again downwards. This is not applicable because summation of the summation flag is false. Then go to the else part, and then check if it is null. Yes, it is null, so we are going to do nothing. This operation of this is complete, so we are going to loop again forward. Remember the pending loop over here which was here, so we were at index 1. We are going to add 1, as you can see, to go to 2. I didn't want to go to 2. We are going to call next, then we are at 3, then pass 3 in this employee ID, so we are going to come here with 3, employee 3. So employee 3 is equal to employee 3, so summation is applicable. If summation is applicable, start incrementing the budget, which is we are going to add 800 to 0, you get 800, and check if next is null. Yes, it is null. So if it is null, the operation is complete, and then the loop has already completed over here, so the budget of employee 3 is 800. So this continues on and on and on and on. That is how salary budget is calculated, and I appreciate so much, and thank you for your time. Thank you.